Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of bi-weekly contest 78. It's a medium level problem. The problem name is number of ways to split array. So we are given a zero index integer array of length n uh, called nums. Nums contains a valid split at index I if the following are true. So there are two conditions. So the first one is the sum of the first I plus 1 elements is greater than or equal to sum of last n minus I minus 1 elements. And the second condition is there is at least one element to the right of I. That means the index that you have chosen should not be the last index. Now we need to return the number of valid splits in num. Let's try to understand the problem with the help of the given example. So we are given an integer array 10, 4, minus 8 and 7. Uh, and let's check what are the splits. Forget about valid splits. Let's check what are the splits. So if we split the array at index 0, so that means there will be two sums. The first one will be of first I plus 1 elements, and the second one will be the remaining sum. That means the total sum minus the sum of I plus 1 element. So that means some split number at index 0. So the first part becomes 10, so its sum is 10, and the second part becomes 4 minus 8 and 7, whose sum is 3. Now since 10 is greater than or equal to 3, I equals to 0 is a valid split. That means you can split the array at index 0. Now let's consider the second possibility. If you split the index at if you split the array at index 1, then the first part becomes 10 comma 4, having a sum of 14, and the second part becomes minus 8 7, having a sum of minus 1. Now again 14 is greater than minus 1, that means the sum of first part is greater than or equal to the sum of second part, so it's a valid split. Let's consider the third index, that I mean the second index, third number and the second index. So the first part is 10 4 minus 8, having a sum of 6, and the second part is just 7, having a sum of 7. So 6 is less than 7. That means 6 is not greater than or equal to 7. So this is not a valid split. Now the last element, that means I equals to 3, will not be a valid split because it says that there is at least one element to the right of I. That means we need to split the array at every possible index except the last index. So we'll skip the last index. Uh, Similarly, if we look into the second example, so there are three possibilities splitting at index 0, 1 and 2. Will not consider the third one splitting at the last index. So in the first case again, we see that the sum of first part is 2 and the sum of second part is 4, so this will not be a valid split. If we consider splitting at index 1, so the sum of first part will be 5 and the sum of second part will be 1, it's a valid split. And if we consider the next possibility, so it's sum of 2 3 1 will be 6 and 0, so again a valid split. Last one will not consider. And let's look into the constraints, because the problem is a simple implementation based problem, but the constraints tell you what the trick is. Like for example, the number of elements in the number of elements in the array can go up to 10 raised to 5, and the value of each number can go up to can vary between minus 10 raised to 5 to 10 raised to 5. So let's see what could be a possible approach to solve this problem. uh, so suppose you are given an array. Suppose this is the array. Suppose you have some elements. So all you need to do, it says that for any index I, you need to consider the sum of these numbers. That means first I plus 1 elements and the sum of remaining elements. And if the sum of this part A, is greater than or equal to sum of part B, then you are good to go. It's a valid split. And just given one condition, the index I should not be the last index. So that means forget about this one. So you will be splitting at this all the positions except the last position. So this is the condition. Now one of the approaches could be that for every index we calculate, like for suppose this is the index, we calculate the sum of this array and then we calculate the sum of this array. That means we run nested loops, but that will time out because the length of the array is 10 raised to the power 5, so that is not the best of the solutions. Another possible approach is that we can compute the sum of all the elements of the array. That means if we know the total sum, suppose we know the total sum, then if we find the sum of first part, that is A, then what will be the sum of second part, that is B? It will be B equals to total sum minus sum of part A. So once we know these two values, total sum and the sum of current subarray, then we'll be able to compute the sum of remaining elements. So in one iteration, we'll calculate the sum of all the elements, and in the second iteration, what we can do is that for every index I, keep on updating the sum. That means, for example, suppose you have calculated the sum till here. So when you reach I equals to 2, just add this element to the sum that you have calculated till now. So you know the sum of this array, and you can compute the sum of this subarray by total sum minus the current sum that you have. So that's the approach that we'll use. It will be a linear time algorithm, and for every valid split, we'll just increment our answer. Let's look into the code. So the tricky part that I was telling you. So the first is we have to calculate the total sum. We have a variable. Now the data type of the variable is long. Reason being, the number of elements can go up to 10 raised to the power 5, and each value can go up to 10 raised to the power 5. That means the total sum can go up to 10 raised to the power 10. Now that will overflow if we take an integer data type. So that's why we have taken a long data type here. And so this was the main thing. Otherwise, in case of overflow, the value would have been negative, and you would have got a wrong answer. So we calculate the total sum in this array, uh, in this loop. We calculate the total sum of the array, and then we have a variable long sum. Again, this will be having a long data type, and then we initialize a variable answer. Then we start traversing the array for I equals to 0 and less than nums of length minus 1, because we need to skip the last index, because the question says that there need to be at least one element after the split index that you have chosen. So that is why we calculate the current sum, we update it with the current number, and then we check if the current sum, that means sum of part A, is greater than or equal to total sum minus current sum, that means the sum of part B. Then we increment our answer, and finally we return the answer. So again, it's an implementation based question, and these type of questions are typically solved um, using the concept that you calculate the sum of complete array, and then while traversing next time, you keep on updating your variable, you keep on updating your current sum variable, and at any particular point of time you will be able to get this sum of the remaining elements, and then we are good to go. It will be a linear time algorithm, and yeah, this is the solution. And hope you learned something new from this video. Do support it by giving up a thumbs up. Also do subscribe to the channel to receive updates of all the Leetcode challenges. Thank you.